Hey guys, welcome to this session on how to become a machine learning engineer by Intellipaat. Machine learning is probably one of the hottest field right now and it's very important to learn how machine learning works. But there's a lot of jargon associated with machine learning and machine learning engineering, and this is why we've brought this session to you to demystify what machine learning is and how you can become a machine learning engineer. Before we begin, do subscribe to our YouTube channel to never miss another update. Now let's begin. So in this session, we'll take a look at what is machine learning. We'll take a look at how it's different from traditional programming. We'll take a look at what are the uses of machine learning, where is it used. Then we'll take a look at the machine learning process. How is a machine learning model built? What are the steps that are taken in building a machine learning model? And then we'll take a look at the steps that you can take to become a machine learning engineer. And finally, we'll have a demo. So let's begin. Let's have an introduction to machine learning. So what is machine learning? Although it's one of the most popular terms right now, not a lot of people understand what machine learning is. So machine learning basically allows you to solve complicated problems by allowing the computers to learn how to infer patterns. Basically, it allows the computers to learn how to map one sort of input to another sort of output. And this is learned by the computer in the same way that a baby learns how to associate a word with an image. So this is why it's called machine learning. So when we're using machine learning, it allows developers to use large amounts of data, really massive amounts of data, and a lot of computational power to solve these kind of problems. Now, since we do have all of these large amounts of data and large amounts of computation power, we can train machine learning models more effectively than ever before. This is why machine learning is so prevalent right now than it was before. So let's take a look at how it's different from traditional programming. So when application developers build applications, how is that different from building applications that are powered by machine learning? So in traditional programming, what we do is we take users input, process it through the program, and process it through the program, and then map it to the output. And in machine learning, what we do is we do some opposite steps. So instead of mapping input from program to output, what we do is we take the input, we use some algorithms to understand how the input is mapping to the output, and then finally we take a look at and we get the rules that we need for the input to be mapped to the output, which is our program. So instead of explicitly programming the rules that we need to convert the input to the output, the machine will figure it out themselves. All we need to do is provide them a really good set of examples that contain inputs being mapped to outputs, or the thing that we want to predict and the data that we want to give it to. So now let's take a look at some of the machine learning use cases. Machine learning, as I said, is prevalent in many domains. So it's not necessarily just computing. Machine learning is now used in almost every industry, beginning with healthcare. So in healthcare, machine learning is used to do a variety of tasks, mainly to assist doctors. The doctors are still the people who are calling the shots, but these machine learning systems can take a look at the scans of the patients and take a look at their records and their blood levels and every information that's vital to the answer that is being given, and it maps it to an output, or either gives it a likelihood or the chances of a patient having a certain disease or being free of a certain disease. So that's where it comes in healthcare. Then there's automation. So machines being automated to do stuff that humans can do, but there are certain tasks that machines have been known to do better than humans. However, there are other tasks that take a bit of understanding of data. These kinds of tasks are automated using machine learning. So they use machine learning technologies to get some good set of data, and then train that data, using that data, train the machine learning model to perform the automations that need to be done. And there's security. So facial recognition systems can be one of them. They allow you to figure out how to identify if a user is a said user. Many captcha systems now also use some machine learning techniques to figure out whether a user is behaving like a bot or not, and then classify them accordingly. And finance. So things like credit card fraud detection, check fraud detection, these are the kind of things where machine learning comes into play. and helps the banks and the other financing entities to figure out whether or not a customer could be potentially frauding the system or not. Now, these are just a few of the things that I have mentioned. There are many industries that have been impacted by machine learning and are using machine learning directly in their daily products. So these are just one few of them. Now let's take a look at the machine learning process. How does machine learning work? So we begin by gathering data. As said, machine learning mainly works on mapping input to output, and we need really a large, massive set of data to get a good model. Now gathering the data is just the beginning of the machine learning pipeline. So what we end up doing is we first gather data from a lot of sources. These could be from institutions, we could survey, we could get data from sensors. There are a lot of places to get data nowadays, and we get the data from those sources and collect them in places where we can use them for our machine learning pipeline. Then we prepare the data. So the data that we get is not going to be 100% correct. We will get some errors, we will get data in different metrics. So we could get different formats of data, and all of that needs to be accounted for and then converted into a normalized set that could be put through a machine learning system, and outputs could be generated. Then there's the step of choosing a model. Now there are several algorithms and several models available in machine learning to be used to perform certain tasks. Having a good understanding of which model to be used when is very handy, and it allows us to pick a model that would best solve the problem that we're trying to solve. Then comes the training phase. In the training phase, we basically take a portion of the data and train our model on that data, and we do it iteratively to find the best model that we can use, and we train our model on that data so that our model can get some data and then predict some output. Then comes evaluation. This is where we test whether the model has been trained successfully and is performing the way we wish it to. So whether it's classifying the things that we want it to correctly, whether it's predicting the house prices that we want it to correctly, so on and so forth. Then comes the tuning phase. In the tuning phase, what we end up doing is we get the data, and after getting the data, we evaluated it, and we have trained the model, and we have evaluated it, and we have understood what this machine learning model is doing. Now if the model is not performing up to our expectations, we tune it. Tuning basically means that setting several hyperparameters on a machine learning model. Now this could be a bit difficult for you to understand. Don't worry, I'll guide you through some resources that can help you understand these steps more clearly at the end of the slide. And finally, it's the prediction, or as you can call it, we deploy the model in the real world, and then the data is given to the model and it produces the information that we want it to be mapped to. And this is the final step. And now this process is iterative, so if we get more data, then we go through this process again and again and again, and the model keeps getting better and better depending on the data that you get and how you're training it. Now here is a job description for a machine learning engineer. So as you can see, you need to understand how to transform the data. This correctly maps to the pipeline that we previously described. We need to understand how to design a machine learning system. You need to understand how to research and implement the algorithms. You need to understand the requirements that you are trying to satisfy, the objective of your machine learning model. Understand how to get appropriate data sets and how to figure out which one is the best for you. And then you can test it, analyze it, and then retrain it, similarly as our steps mentioned previously. Now let's take a look at the companies that are using machine learning. So one of the companies that's using machine learning is Netflix. Netflix uses machine learning for their movie recommendation system. So when you see the feature that says people who watched what you watched also watched these shows or these movies, this is where Netflix takes in the massive amounts of data that it collects from the user and trains a machine learning model and gives you the best recommendations it can. Then comes Google. Google uses machine learning extensively. So you could see Google using machine learning in their ads platform. You could see them using them in the recommendations platform, the search engine platform, and there are many other platforms that Google has created which uses machine learning. Then there's Twitter. So in Twitter, machine learning is used for many purposes. One of the most famous ones is that it's used to figure out whether a tweet is offensive or should be banned from the community or not. This is where Twitter uses machine learning. Then there's Quora. Quora uses machine learning similarly to Twitter to figure out whether something is plagiarized, something is containing something that's offensive, that's breaking the guidelines that are set by Quora. Then there's IBM. IBM uses machine learning a lot, especially in their internal tools, and also it has a machine learning platform called Watson, which it has made public, so people can use it. Supposedly, if they are paying the appropriate price. Then there's Apple. Apple uses machine learning a lot as well, especially when you are using Siri, which is the Apple's voice assistant. That uses machine learning extensively and as well. Now let's take a look at the steps that you need to take to become a machine learning engineer. So the first thing that you need to do is you need to get comfortable with mathematics. Now mathematics is quite a scary thing, and don't worry, if you don't know any mathematics, you need to wait till the end of this presentation and I'll show you or guide you to the resources that you could use to get comfortable with mathematics and proceed to other steps in machine learning. Then you need to learn programming. You also need to get certified. Then you have to build a portfolio, and then you can start applying for jobs. So when it comes to learning mathematics, what the main thing that you need to understand is you need to learn linear algebra, calculus, statistics, and probability. You don't need to be an expert in all of these, but there are certain aspects of these subdomains of mathematics that are used in machine learning. So you need to understand those topics, how to use them, why are we using them, and when you can use them, and you'll be good to go. Then there's programming. So programming is essentially you use a computer to perform certain tasks. In this case, we use the computer and program it to create a machine learning model from the data that we're providing it. Now, many programming languages are available for you to use in machine learning. Most popularly, people use R and Python. R is mostly used in academic and research scenarios, while Python is mostly used in software development and using machine learning in normal day softwares. So you can use them. Now that's not necessary that you only use R and Python. There are other languages that use machine learning as well. However, Python and R have great support for machine learning and other things. So this is why these are the most famous ones. Then you need to get certified. Certification really helps in setting yourself apart from the crowd in the eyes of the recruiter. So when a recruiter looks at a resume and sees that he's certified or a person is certified, then it gives them a higher probability that this person knows what they're claiming to know, and they can proceed further with that applicant. So knowing or getting a good certification is very, very helpful. Then you need to build a portfolio. You can basically use your machine learning skills that you acquired during the certification or your learning phase, and you can use it and apply it to the tasks that you see on a daily basis. This also shows the recruiter that you are very passionate about the machine learning scenario, and you want to learn more about machine learning, which is always a positive sign for the recruiters. Then you get to apply for the jobs. Now when you apply for the jobs, you are certified, you have built a portfolio. These are really great indicators for recruiters, and they'll probably shortlist you if you are following these steps. So now let's take a look at the demo. So a recent survey that was conducted by the International Diabetes Federation showed that 371 million people worldwide had diabetes, and 187 million of them did not have any idea that they had that disease. So that's very difficult. So let's see what we are doing. So let's try and use some diabetes data set and build a model that will predict whether a person, given some information, has diabetes or not. So I am in Google Colab. This is an online environment created by Google. You can use it for free, and you can run Python code that you could write and understand how to use it, and then you can run it inside this Colab environment and create machine learning models online, and you can collab with other people as well. This is completely free, and it's an awesome resource. So what we're doing right now is we are using some code, and it's not necessary that you understand it right away. It's fine because you are just beginning, so you don't have to worry about understanding it completely. Just take a look at how a problem is solved using machine learning, what are the steps that are taken, and hopefully you can get away with some information with it. And don't worry if you don't understand it, stick with me till the end of the slide and I'll guide you through some resources that will help you. So after we have set up our libraries and we have installed or we have imported everything that we need through the Colab environment, now we need to upload the dataset. So we run this cell and it will show us a button that will allow us to upload a file. Okay, let's see. Okay, yeah, it shows some error. Never mind. I could just use this as well. Basically, I just need to go to files, click on upload, and then I have to download. I have to use the diabetes dataset. Okay, and as you can see, diabetes.csv is the file that we'll be using. It's 23.31 KB. It's uploaded. Now comes the step of data preparation. Now in our case, data preparation is not going to be that difficult because it's gotten from the UCI machine learning repository. So it's already prepared. It's got normalized data sets and everything. So you don't need to worry about preparing the data. But in case you were working it in a real life environment, there you would have to use some data preparation techniques and get the data into the normalized format that you can use. Now let's try and use the diabetes.csv file. So we run this, and these are the columns that are inside our data set. We have pregnancies, glucose, blood pressure, so on and so forth. The last column, outcome, is the thing that we're trying to predict. Let's take a look at some of the rows in the data set. So we have quite a few rows, but we are displaying only the first 5 ones. So this is what the data looks like, and the outcome is binary outcome. Basically it contains 0 and 1. 0 means that the person did not have diabetes, and 1 means that the person did have diabetes. And these are all the informations that we have. Now we can visualize the data. Visualizing really helps in understanding what our data looks like, what is the mean, what are the ranges that the data or different columns contain the data in. So we run the visualization. It starts, and as you can see, we have plotted histogram for all of our columns, 9 columns as you can see, and this is what it looks like. Now let's take a look at if we have null points. Null basically means that there are some data points that are unavailable. So we have just skipped them. The data was not available at that time. And if we do, then we would have to do certain things. Let's see. So is null and is NA are both the same. Null means a null is a value that is used to represent the absence of some value. And A means that the value was not present in the cell at all. It was completely blank. So we have 0 NA and 0 null values, which means that our data set is completely fine. Now we'll be taking a look at some of the outliers. Outliers basically means data that is not correct, or the data that is outside the normal bounds. So as we can see that a person with a blood pressure of 0 could not exist. So let's take a look at how many we have. So we have 19 people with blood pressure as 0, and 16 people at blood pressure as 0, and people who are predicted to have diabetes. So that's fine. Now let's take a look at the glucose level. Does a person with a glucose level 0 exist? Yes, today are total 5 people who exist. 3 of them have been predicted to not have diabetes, and 2 of them have diabetes. And similarly, the skin thickness is also 0, which is also not possible, but we have 227 records for that. And let's take a look at the BMI, which stands for body mass index. And here we have 11 records with BMI as 0. So now let's take a look at insulin, where insulin is 0. And we have around 374 records. Now this is where the domain experts come in. So if you don't know whether a person can have insulin as 0 or not, or any other aspect that you do not understand, the domain experts help you out in understanding whether or not that data set should be allowed in the model or not. Depending on that, then you can remove these things. So as you can see, we'll be removing everything from our diabetes data set that contains with the blood pressure as 0, or the BMI as 0, and the glucose as 0. So if all these 3 things are 0, then we remove them and we store the clean result in the database _mod variable. So we run that, and it contains 724 records with 9 columns. Now comes the model selection phase. So before selecting the model, we will split our data into the input that we'll provide and the output we want it to be mapped to. So the outcome is the output, and everything else, as you can see up in the column, is the input. So we run that, it runs fine. Now comes model selection. So to do that, firstly we'll import a bunch of stuff. You may not understand what all of these things are, that's fine. You don't need to understand it right now. Just stick with me till the end of the presentation and I'll show you what it means. So firstly, we'll create a few models and store them in the models list. Now these are the models that we'll be using and evaluating our program on. We split the data set and yeah, now we split it into training and testing set. So basically we will train the model on some data and then test it on some data that we've set aside, and we'll test whether or not it's working or what's the accuracy. Now let's train our models and take a look at the accuracies. So we have accuracies of 77.9, which is around 78% in logistic regression, and there are other algorithms that are performing these way. So these are all the accuracies that we are getting, but it's a bit difficult to understand, so we'll visualize it later. Now let's take another look at how to check the accuracy of models using the k-fold method. So k-fold method basically splits the data into 10 buckets and then randomly uses one bucket to validate the data and 9 buckets to train it. So it's a more comprehensive way of testing the data. So we have got the accuracy scores now. Now we can take a look at it, and it's easy to see and understand what this is, but suppose we had 15 models, that would be very difficult for us to get an idea of which is the model that's performing the best. So instead of doing that, what we do is we visualize it, and as you can see, the bar with the highest, or the bar with the highest, or the model with the highest bar is the logistic regression one. So when we're training the model, we'll be using logistic regression, and then we'll go ahead. Since we have chosen the model, now all we have to do is we need to get more data, train our model on that data, and get as much data as you possibly can, and then train your model. This could take a lot of time because crunching through the entire data set could be a little difficult. So you do that, you train the model. After training the model, you tune it if necessary, and tuning it is a bit of an advanced topic, that's why we've left it out of here, but you can learn it. I'll guide you through some of the resources that will show you how to do that, and finally you can deploy it in any way, shape or form you want, maybe a mobile application, maybe a web service, so on and so forth, and it'll work just fine. Now let's take a look at some of the resources that we'll be using. So how to further your learning, how to get started, how to go ahead in your machine learning journey, let's take a look at that. So whenever I think about learning new things, I think of this quote from Benjamin Franklin. It says, "An investment in knowledge always pays the best interest," which is a beautiful quote and gets to the heart of what is actually meaningful. So we at Intellipaat provide a great set of resources for you to learn these things. We have blogs that contain a lot of information, a lot of content about machine learning and many other technologies as well. Now if you want to learn through a more visual medium, you could learn through YouTube. We have a YouTube channel. That channel contains a lot of information, a lot of videos about a lot of technologies, machine learning included, and can help you get started with machine learning in no time. But let's say that you have exhausted the content and you want to dive deeper. In that case, here's a course that can help you do that. On Intellipaat, we provide a machine learning course. It's very comprehensive. It's one of our most highly reviewed courses. It has instructor-led training, about 32 hours of content for that, 32 hours content for self-paced training. We have exercises and project works. These project works can be included in your portfolio, and you can show them to your recruiters that I built these projects on my own. And you get a certification that is recognized by the industry that helps you set apart. You get flexible scheduling, lifetime upgrade, and 24/7 lifetime support. The machine learning course includes a lot of content, designing from training machine learning using data. You get to learn artificial neural networks, linear regression, and Python, and so on and so forth. And you can learn a lot of other things as well, like some advanced topics like principal component analysis, data modeling, and so on. These are some of the questions. If you have a few questions, you can ask them here as well. Now, as you can see, that this is the course content, and it's very comprehensive. It teaches you most of the things that you might need to know to become a machine learning engineer, from time series analysis, natural language processing, so on and so forth. You have around 7 projects. You get really good project insight. Here's a video for you to sample and take a look at. This is what the certification would look like. Imagine your name here, and this certificate is valid in many of the top 100 IT companies like Cisco, Ericsson, Cognizant, and so on. These companies accept these certifications. Now we have a lot of content as well on our site. You can take a look at some of the reviews that you get. You could take a look at some of the questions that have been frequently asked. But supposing that your question is not listed here, you might have a question that is not listed here and you want to get some answer to that question. So before going to that, you get a 30% off using this coupon code. This is for especially for the YouTube viewers. So you could use this coupon code today. It's valid for today. Buying any course and you'll get a flat 30% off on any course that you buy using the YouTube 30 coupon code on our website intellipaat.com. Now, in case you have any other questions, any other queries, you want to know about any other course, you want to get a deep understanding of what the course is like, any other questions regarding anything, you could contact our course supervisors or course advisors. You could contact us on these numbers that are provided on the screen, or you could contact us on the email that's provided on our screen. Our advisors are 24/7 ready to talk to you, and they will help you guide you to the best course that satisfies your need. And with that in mind, thank you so much for joining me. Hopefully this has been beneficial for you, and thank you.